Welcome to this tutorial on the if and ifs functions in Excel. Let's start by understanding something fundamental: true and false. Excel uses true and false as logical values to represent the outcome of a condition or a comparison. For example, if you compare two numbers, like this formula, Excel will return true if the value in A1 is greater than the value in A2, or false if it is not. In Excel, true is equivalent to the number 1, and false is equivalent to the number 0 when used in calculations. For instance, if you write true plus 1, Excel will give you the result 2. Similarly, false plus 1 will return 1. The if and ifs functions use logical tests that result in true or false to decide what output to return. Essentially, you're asking Excel to evaluate a condition and take action based on the result. Let's start with the if function. This function lets you create a simple decision-making process. In the formula shown on the screen, if the value in A1 is greater than A2, Excel will return yes. If not, it will return no. Let's look at a practical example. Imagine you want to evaluate sales performance and categorize it as either good or needs improvement, based on a target of selling at least 5 items. Here's the formula you would use. This formula checks if the value in cell C2 is greater than or equal to 5. If it is, the result will be good. Otherwise, it will return needs improvement. For example, if the value in C2 is 4, the formula will return needs improvement. Now, to apply this formula to all rows, simply double-click the fill handle, and Excel will copy the formula down the column. Once applied, you'll notice that products with 5 or more units sold are labeled as good, while those with less than 5 units sold are categorized as needs improvement. Instead of hard-coding the text good and needs improvement directly into the if function, you can store these values in cells and reference them in your formula. This approach makes your formulas more flexible and easier to update. For example, let's write good in cell G2 and needs improvement in cell G3. Then we update our formula to reference these cells. Why is this useful? If you ever need to change the labels, for instance, replacing needs improvement with below target, you can simply edit the text in G3, and the formula will automatically update across all rows. This eliminates the need to manually edit the formula itself, saving you time and reducing the chance of errors. By using cell references, you're making your formulas more dynamic and adaptable to changes. The if function isn't just for displaying messages based on cell values. It can also perform calculations directly within the formula. Let's see how this works with a practical example. Suppose you want to apply a 2% discount to products priced at $500 or above. For products priced below $500, no discount will be applied. To achieve this, we use the formula shown on the screen. Here's how it works. The formula first checks if the value in B2, the product price, is greater than or equal to 500. If the condition is true, it calculates 2% of the price in B2 by multiplying it with 2%. If the condition is false, the price is less than 500. The formula returns 0, indicating no discount. For example, if B2 equals 800, the formula will calculate 800 multiply 2%, which equals 16. If B2 equals 450, the formula will return 0 because the price doesn't meet the condition. This demonstrates the versatility of the if function. It not only allows you to categorize data, but also to perform calculations dynamically based on specific conditions. Next, let's talk about nested if functions, a powerful way to handle multiple conditions in Excel. But first, what exactly is a nested if? A nested if is when you use multiple if functions inside one another to evaluate more than one condition. It allows you to create complex decision-making logic within a single formula. Let's build on the example from earlier, where we applied a 2% discount to items priced at $500 or above. What if you want to offer different discount rates based on the product price? For instance, a 2% discount for prices of $500 or above, a 3% discount for prices of $1,000 or above, a 5% discount for prices of $1,500 or above, and a 7% discount for prices of $2,000 or above. You can achieve this using a nested if formula shown on the screen. Here's how the formula works. It starts by checking if the price in B2 is $2,000 or more. If true, it calculates 7% of the price. If not, it moves to the next condition. Is the price $1,500 or more? If true, it calculates 5% of the price. If that condition isn't met, it checks if the price is $1,000 or more and applies 3%, and so on. Finally, if none of these conditions are true, the price is below $500. The formula returns 0. Once you've written the formula, double-click the fill handle to copy it down the column, and apply it to the entire dataset. Now, each product will have the correct discount calculated based on its price. This is how nested if functions enable you to handle multiple conditions efficiently. However, as your logic becomes more complex, it's worth considering alternatives like the ifs function, which can simplify your formulas and make them easier to read. So next, let's talk about the ifs function. The ifs function is designed specifically for testing multiple conditions without the need to nest multiple if functions. It provides a cleaner and more straightforward way to handle complex logic. Here's how the ifs function works. It evaluates conditions in the order they are written, and as soon as it finds a condition that is true, it returns the corresponding result. You don't need to add else logic like in the nested if function, because the ifs function stops evaluating once a condition is met. For example, let's recreate the same discount scenario using the ifs function. The first condition checks if the price in B2 is $2,000 or more. If true, it calculates 7% of the price. If not, it checks if the price is $1,500 or more, and so on, following the same logic as our nested if formula. As you can see, the ifs function eliminates the need for multiple parentheses, making the formula shorter and easier to understand. One important thing to note about the ifs function is that it doesn't return a value if none of the conditions are true. Instead, it will result in an #n/a error. To prevent this, you can add an additional condition, which checks if the price is less than $500 and then returns 0. This works because the ifs function doesn't have a built-in argument for handling a false condition. Alternatively, you can include a true condition at the end of your formula, as shown on the screen, to act as a fallback or default value. The true condition ensures that if none of the previous conditions are met, the formula will return a specified result instead of an error. This flexibility allows you to handle all possible scenarios and make your formulas error-free. Thank you for watching. I hope you found this tutorial on the if and ifs functions helpful. If you did, please share with others. Don't forget to like, subscribe, and hit the notification bell so you never miss an update on our latest Excel tips and tutorials. Your support helps us create more valuable content for you. Thanks again, and I'll see you in the next video.